All right. So today we are going to learn about create, read, update, delete in Django. We already got a bit of a preview with this Friday, talking about REST APIs. And we're actually going to start with updating Pokemon with what's called a put request. I'll do a little bit of a review of the concept of a REST API in general. Um, but we'll start with updating Pokemon because that's a little more straightforward since we have Pokemon. We'll also see how to write tests for this as we go. And then in the second part, we'll be doing create and delete. And could I actually get a volunteer? We're going to do a little bit of reading. And could someone actually just read this first paragraph here, please?
By learning that CRUD operations and RESTful API design while building a Pokedex clone API, you are aiming to create a robust and user-friendly API that allows for efficient management of Pokemon data. CRUD operations create, read, update, delete form the fundamental actions needed to interact with data, enabling you to add new Pokemon, retrieve their info, update their details, and remove them when necessary. RESTful API design principles ensure that your API is structured in a logical and standardized manner, making it easy for developers to understand, use, and extend. This knowledge empowers you to build an API that seamlessly integrates with various applications, providing a consistent and intuitive interface for users and developers to interact with Pokemon data, fostering interoperability and scalability.
Yeah, I know that's a mouthful. Thank you, Chase. That was awesome. This touches on why this design pattern of a RESTful API, and we'll break down the acronym in just a minute, is so valuable. This term CRUD, you'll hear it used to talk about like because these are the basic things you can do with data, right? You can create it, you can read it if it already exists, you can update it if it already exists, and you can delete it. So these are the common database operations. And then when we're writing a web application to interact with the database, a backend web app, these are usually the first things you want to implement for most stuff. So you'll hear CRUD used all over the place. And then we follow the patterns of designing a REST API, usually to implement CRUD, right? To be able to do these things. And this way, the whole internet doesn't have direct access to our database. And like you were saying, from reading this chase, RESTful API design has really become a sort of standard pattern. Um, and let's talk a little bit about this, and then I'll draw up some more examples, and then we'll write some more code. So CRUD we've talked about, creating we've talked about, reading existing data. Um, we don't think about it a lot in this course, but if you think about if you're, say, Netflix and a really exciting new movie comes out and everyone's trying to watch it at the same time, is that going to overload some sort of server or database? So right now for us, reading is pretty straightforward, but this is actually where a lot of traffic comes from. Updating existing data, the concept is pretty straightforward, as is deleting. And for deleting, obviously, we'll want to think about certain rules around like what can a user delete, what can a user not delete. Um, Let me talk real quick about the word API. Let's go to Wikipedia. So Wikipedia says an application programming interface is a connection between computers or between computer programs. It is a type of software interface offering services to other pieces of software. So this is a pretty broad general term, right? And there's a lot of different kinds of APIs. And in fact, like when we use Django REST framework,
Connect.
if we go to their docs, um, they have what's called an API guide, but this is not about REST APIs. This is about the interface to all of these classes. So you'll often hear the term API used to describe like a third-party library of code that we're using. And this is for us to understand how we should use this code, right? Because this is the interface for our Django code to interact with Django REST framework. But this doesn't have anything to do with like sending HTTP requests over the internet. Most of the time, you'll hear us talking about REST APIs. And for the personal project, when we talk about third-party APIs, we're talking about REST APIs. So what the heck is this REST that we keep seeing? Um, it stands, it's a mouthful, but it stands for representational state transfer. And the idea is, well, I know I want to store data, but how do I send it over the internet? And how can I create a way where I don't have to, install some Python code to interact with the server? Is there a way that we could do this with HTTP requests, where just by using HTTP requests, by using those verbs, get, post, put, delete, and the URL, is there a way I can design an interface so that any kind of program that can send an HTTP request can ask the server to create data or read data or update data? Um, if I search around for, that's actually a pretty amazing site. We'll come back to that one in a second. Um, so this was actually created. When was this created? Some point in the 90s. It was actually the PhD thesis, here we go, of this guy, Ray Fielding. Yeah, Roy Fielding. Um, he came up with REST as part of his PhD thesis in 2000. So this had sort of been floating around, but like this sort of standardized it. There's actually a whole lot more to the idea behind a REST API, but we've seen sort of the core idea here. You'll hear this term resource thrown around a lot. And when you hear resource, think data model or database table. Think Pokemon, right? We have a table for the Pokemon in Postgres, but we also have a Django model. And we'll probably have a React component like a Pokemon card. So a Pokemon is an entity or a resource if we're sort of designing our universe, right? And the idea of a REST API is I need to just make my HTTP requests for the resources I want to interact with, but I don't have to care about if it's Django or Node.js or my grandmother and a team of hamsters on hamster wheels that are doing all the work to get the data and how the data lives. Um, so the big ideas with with REST architecture, the first is this client server separation, and we've seen that in action, right? That's our browser or our React app running in the browser, and our Django backend is the client, or excuse me, our Django backend is the server, and our React app is the client. Stateless, we haven't talked a lot about, but the idea here is that every HTTP request has all the information that we need, right? When you send a GET request to get a Pokemon, we don't have to have already established a connection to our Django server or anything like that. All the information we need is in the HTTP request. And while our Django server needs to be running, we don't have to have like a user logged in or anything like that. Caching is a little bit out of scope to talk about right now. The idea of a uniform interface, we've already started to see the idea there is consistency in how we design our URLs, in how we use get or post or put those HTTP verbs, and also consistent HTTP response codes. Um, so those are the big ideas. And if we hop over back to this other article, we kind of see these here again. Again, each request from a client has to contain all the information the server needs. And we've seen this with our HTTP requests. This client server architecture, caching again is a little outside of scope. Consistency, right? And how we have URL paths, HTTP methods, and status codes. And then this last point, layered system, is also a little out of scope, and we're not going to worry about it. And we've kind of seen this already. Some of this has already been a preview, right, of an HTTP request. And here's a resource or a user, and then the user's ID. And here's how we would make a post request to modify that same resource. And in the body, there would be some JSON. And if we wanted to modify the user once they existed, we would do a put. Patch we rarely see, so I won't touch on right now. And then delete would be for obviously deleting a user. You can sort of see here, we just have a little table that summarizes this. Again, consistency in the HTTP methods is the big one. There's also standardizations around HTTP response codes and what they should mean. And in fact, the Mozilla web docs have a whole page on this, and it's really useful to kind of look through this because all this is pretty standardized. As you can see, there's a lot of different kinds of responses, even for success. For instance, the 200 HTTP response is to say that a request succeeded. But if we were using, say, a post request to create something, we're supposed to send back a 201 response to say that this request succeeded and a new resource was created, a new Pokemon was added to the database. Those are by far the most common ones we'll use. Sometimes you might see some of these others, but especially when working with third-party APIs, this is actually really useful. As you can see, there's a number of redirect responses that come up sometimes. There's a category of error responses if the client has done something wrong. So this is how we could tell someone else using our Django API if you made a bad HTTP request. Or so for us to know, okay, I need to go to my React app, maybe to help debug. We haven't talked about authorization yet, but if the user isn't logged in. And then there's different kinds of error codes on the server side. 500 internal server error, which I know we've all seen at some point, is sort of the generic one, right? Saying that just something has gone wrong. But there's a number of like more specific server side errors, though we usually just will send a 500 back. So the point isn't to worry about learning or memorizing all of these. That's what the docs is for. But just to show that this idea of a REST API and these conventions is really well kind of established and built out, and now we kind of get to enter and join this world. Over here too, we've sort of just mapped out. You'll often see people write out or design REST APIs this way, where if we're looking at a Pokemon, we have our create endpoint that's going to be a post, and we would have to put something in the body here in JSON, like, you know, like this. For getting a Pokemon, what you'll often see is this colon followed by a variable name as a placeholder. So an actual URL, as we've seen, would look like this. And then if I wanted to get the moves for that Pokemon, I would put moves here as we see down here. And again, what we sort of see here is like a name spacing and a resource hierarchy. Like this is all Pokemon. And then getting more specific, this is an individual Pokemon, like a subcategory. And then for an individual Pokemon, let's get all of their different moves. And that's the pattern that you'll see like all REST APIs follow, and that you all should do as you design REST APIs as well. And then you can see update here as well. So I know I've done a lot of talking. I just want to pause and see if folks have any questions or things that you're curious about. And how much of this is review and how much of this is new.
I feel like a lot of it's review. There's been a couple new things.
Yeah, totally. So let's design our move REST API real quick. So if I want to create a new move, what would that API endpoint be?
Uh, API/P1/moves probably.
Yep. And what's the HTTP verb? Is it going to be a post, a put, a get, a delete?
Post.
Yeah, exactly. Because post means creating. And when I want to do the name of the move, do I do it like this? Like what I say, like Thunderbolt?
No, you do the little like sideways carrots or whatever, and then like stream
Yeah.
semicolon name.
Yeah, exactly. And it's I see. I think maybe not quite. We would pass JSON in the body of the request. And actually, let's go ahead and use we're going to be using this when we get hands-on in just a minute. Um, there's a great VS Code extension called Thunder Client. And I'll just drop the name in the chat. And if someone can maybe repost that in Slack.
Hey Adam, I guess just to let you know, I
Yeah.
started playing with Postman a little bit over the weekend. Is Thunder Client pretty much kind of like the equivalent? Does the same thing, just it's just in VS Code.
Yeah, they're basically the same. We used to show a lot of Postman. It started like once it started requiring account creation and getting more heavyweight, we just wanted something a little simpler for teaching. Postman is also a really popular tool. Yeah, and I'm gonna show another as well, and it's really dealer's choice as to which one you use. Um, but let's use Thunder Client real quick and let's see it in action. Let's use it just to get all of our Pokemon. And here we see, in fact, that we've got all of our Pokemon, right? So if Django's our server over there, and up until now, we've been having our browser be the client, and then the server sends back a whole bunch of data. It sends back a 200 OK response, and then a whole bunch of Pokemon. But now we actually are going to be indeed using another client, um, Thunder Client. The one you mentioned, Jason, and I'm just going to be a little lazy. We're just going to make this very tall. Postman has been around for ages and is really popular if people want to use that. Um, it's like a separate program that you can use and save stuff for to do what I'm doing now with Thunder Client. I'm going to show you all another tool in a moment as well. What it's really dealer's choice. If you're not sure, start with Thunder Client. If you're not happy with Thunder Client, try Postman. But so Thunder Client just made an HTTP request to our server, and we can see that down here as well. We're all the way over here, get/API/V1 Pokemon. And in Thunder Client, there is some way to save HTTP requests. I don't remember it off the top of my head. Um, Probably if I know there's a way to do it. I'm not going to worry about it right now. And we can see the HTTP response body. If we want to see the response headers, we can see it there, and some some other things. And in fact, I could even copy and paste this if I want to. And we can see if I scroll down a bit, our HTTP request headers. The user agent header, which is set by the client, is now not. It's a browser, it's Thunder client. And there's nothing in the body of this HTTP request. But if I wanted to say, and instead of Pokemon, let's grab all our moves. Well, now I get an error, not found API/v1/moves, probably because I did it singular when it should be plural. And now we do indeed get something back, and we get all the moves back. And if I wanted to use Thunder Client to add a new move, I would need to change the nature of the request and put what I want here in the body, and it would look something like this. Name, I don't know if this exists, but I'm just making it up. Ice freezer, and we would hit send. But we get an internal server error because this endpoint doesn't exist yet, right? And so this is what we're going to create over the course of today. Another nice tool is let's call it like moves.http. What you can do is if you save a file as a .http, and I'll show you all in a moment the extension that I'm using here. We can also send that HTTP request. And it looks like so this one is called REST client internal. And I'll share this, and if someone wants to cross post this as well. And the nice thing about this is if you want to save HTTP requests in a file, you can. And it can support everything else that we do. I just need to, this is probably what I'm missing. It looks like it probably wants me to add this content type application JSON HTTP header. Let's see if that does it. Yeah, so I apologize. I might have to fill around with this one. I use Thunder Client a bit more because it's a bit friendlier and it has a GUI. But we can see now we're going to start wanting to use these tools to interact more with our API. And just to finish building out the moves resource before we start writing code, I've got create. Let's talk about read, right? Get API v1 moves. And if I want an individual move, what is that URL like?
Move/ID.
Yep. And what if I want all the Pokemon who are able to do that move? And this is where looking at other patterns can help. Because if I want to find all the moves belonging to a Pokemon, I do it this way, right? If I want to find all the Pokemon that have a move in terms of REST API, it would look like this. And again, think here like hierarchy, namespacing, resources. I'm not looking at all the moves. I'm getting an individual move. And for that move, I want all the Pokemon that are using that move. Now, does that exist in our code? Will that work? I don't think we've done that at the moment. If I go to the Move app, and I look at my views, there's definitely not an endpoint here for that. In fact, in URLs, PY, we don't even have an individual move. So this is where, especially for your personal projects, like I want to show how if we think of a REST API just in terms of like URLs and verbs, how we would design things. But then here we still have to write the Python code to actually make this work, right? And we may or may not need this depending on what our Pokemon React front-end app does. But this is how, in terms of RESTful API, you would design it. And I just want to check in and see if folks have any questions around sort of conceptually what this REST API endpoint is saying. Are we feeling pretty good? Cool. Awesome. Update, again, pretty straightforward, right? Now, can I have this be an update endpoint? Would this make sense in terms of designing an API? Probably not, right? Because we only can update one move at a time and then delete. Also needs an ID. So should I be able to delete a move that a Pokemon is currently using?
Probably not.
I would agree, probably not.
You can, but
Right, exactly. I can, but I probably don't want to. Do I need to worry about that in designing my REST API?
Yeah.
And this is a little bit of a trick question.
I would say yeah, because if that information is needed somewhere else, it'll be broken once you delete it.
So, yeah, and this is where this is a little bit of a trick question. You are totally correct that we need to think about this when designing our program and writing our code. But if all I'm thinking about is the API right now, if all I'm doing, think about when you read the Poke API docs, right? And we're making those docs now for our app for someone else to use. At this sort of level up, we're not going to worry about that, right? Because we want the feature for the front end, the client, to be able to delete a Pokemon move. Then when we actually implement this in our code, we absolutely will worry about that. And then at that point, in fact, we might even go back over to MDN error codes. And, if I was doing this, I would look around for like a response code that seems like it's about right. Maybe like a 403 forbidden, the client doesn't have access rights. Or maybe even just a 500. But then in the response, we probably would want to give something in the error message saying like unable to delete because move is being used by Pokemon. But in terms of designing the API, that's kind of outside scope, if y'all see what I mean, right? That's not the job of this API interface is to worry about that. That's our job when we go ahead and implement this. And I just want to check in and see if folks have any questions or things you are curious about.
So when we go to like using the update or delete, when we go to that URL, like as like a developer, um, is that then at that URL location, is it going to ask for like information on what we want to delete or
Right.
update?
Great question. Like, do you mean sort of like, hey, if I'm debugging, I can do localhost 8000 API/v1 Pokemon. How do I test and debug this as I'm developing? Or like if I've got a React front end, what URL do I go to like delete Pikachu? Am I in the ball?
Yeah, yeah, essentially.
Yeah, great question. So this is where like the browser hits its limits for us. Like with Django REST framework, if I do this, I think they might let us change the GET request, but the URL to view a Pokemon and to delete a Pokemon is the same, right? Here's viewing an individual Pokemon, here's deleting an individual Pokemon. The URL is the same. The difference is what HTTP verb we set when we make the HTTP request, right? And every single HTTP request in the browser where we're doing it this way from the URL bar is a GET request. Like if I hop over here and I clear this and I get rid of this and I refresh the page, I'm gonna have to scroll all the way up. But that first request, before it starts sending back all the HTML and CSS that makes this look pretty, we've got the URL and we've got the verb, which is a GET request. And this is where Thunder Client comes in. And in VS Code, I usually just do Command Shift P or Control Shift P on Mac or on Windows. I just start typing Thunder Client, new request. Because this is where I can use different kinds of HTTP verbs easily. And so if I want to get information about that Pokemon, I can do it that way. If I want to test deleting that Pokemon, I can do it that way. And we haven't implemented delete, so, and it seems to want a trailing slash anyway, but it still won't work because we haven't implemented delete. And in fact, we get this response 405 method not allowed that Django REST framework has given us for free because we haven't created it yet. Does that help answer your question, Chase?
Yeah, so like with like the back end stuff, like if we're trying to do like a delete or update, there has to be like a specific URL path for that.
The URL path, there's two parts here. And let me go back to, let's see, do we have it in the chart?
I might just be a bit confused too.
Yeah. Think about it this way. With a REST API, there's really three parts. The HTTP verb, that's one of the request headers. There's the URL, and then if we send it, there's JSON in the body of the request. The URL's job is to identify the resource. Like right here, this says, I want a Pokemon with ID 1 or whatever ID it is. The verb's job is to tell the server what we want to do with that resource. I want to get that information. I want to modify that Pokemon. I want to delete that Pokemon. So this is adding something new into the mix. And this is where to test it out. We can't just use the browser in the URL bar because the browser will always send a GET request. So the URL stays the same. but the verb changes. And the verb ends up being super important. Does that help answer your question?
Yeah, yeah, that does.
Awesome. Yeah. And this is where like we haven't seen this a ton, and I think seeing it in action will help. And I do want to, if I can just get this working, it would be nice because it's nice to see it. I'll just to show it to show a simpler one. Like let's just do get API v1 and let's get rid of this stuff. And let's see if it lets me send this one. So this is what I wanted to show earlier. I'll follow up with the right syntax for adding something in the body of the request, but this is using a different VS Code extension. And if you prefer kind of putting it in a file, and then you can see like the full HTTP response here with the code and all the other headers and the data. This Thunder client, Postman, they'll all do the same thing. And so if I wanted to delete this Pokemon, I would do it this way. But of course, that sends an error. And in this case, it looks like a 500 internal server error. The Pokemon doesn't exist. Or, excuse me, the delete method doesn't exist. So it's not going to work for us. Delete not allowed. And that's what we're going to build in a minute. So let's actually move on and let's start doing some building of Pokemon so we can see this in action. We're going to start with put, which is modifying. And we're in fact going to modify a Pokemon. So what I want to be able to do is for a Pokemon with the given ID, I want to be able to modify their information. And let's say I want to be able to change the Pokemon's captured status. So to go back to, and let me close out some of these that we're not using at the moment. To go back to our sort of REST API design, put is for updating something existing, and the new data we want goes as JSON in the body of that request. So here I want to change, I believe Pokemon with ID of one is Pikachu. I want to change their status to true. And obviously this doesn't work right now because we haven't implemented a put method. But this is what I wanted to set up the test so that once we do implement, we can click on this and we can get it working. So let's write some code and build this out. And just to go through this step by step, if we go to the URLs PY for our Pokemon project, over here we see API/v1 Pokemon, and then the routing points to URLs PY in our Pokemon app. So I don't need to touch anything here in the URLs PY for the project. And if I go to the Pokemon app URLs PY, I see that we've got two different paths really. One is for all the Pokemon, and that's not what I care about right now because my goal is I want to be able to do, put API v1 Pokemon. I want to be able to hit this endpoint and pass some data and have that update. So this path right here looks a lot more like the one I want to deal with, right? We already have this route set up, and we're using this Django REST framework, class-based view. So we can actually go now and modify this already existing view. And let me just select my Python interpreter so I can make those squigglies go away. And so here we finally get to add a second method. Django REST framework does the work of figuring out if the HTTP request, if the verb is get, post, put, or delete. And we have one here for get. Let's add one for put. And right now, let's just return a response. And let's just return an F string that says put request for ID. And let's just put a print statement here that's an F string. And let's just have it say put, let's just have it say a Pokemon put ID. I just want to test that this works. So I'm going to go ahead and kind of clear my console. And I'm going to go over to this put request and send it again. And now we can see that Django REST framework is doing the job of figuring out, oh, this HTTP request, it has its verb is put. I should call this other method. And we can see our code happening here. And this is the built-in sort of Django server console logging. So I just want to check in if folks have any questions there, because this is something that Django REST framework does for us for free, right? With the class-based view, where we have this route already set up, and then Django REST framework will figure out if the HTTP request has a get verb or a post verb or whatever, and it will call the appropriate method that has to have the same name. How are folks feeling about that? We feeling pretty good?
So if you call the put method something else, it wouldn't recognize it. So it strictly has to be called PUT to be recognized.
Exactly. Like if I add a second T here, PUTT, and now let's do this again. We just get the same thing as before, method not allowed. Yeah, so
So
Django,
this is like why we, sorry.
no, go ahead.
So this is like why we're using the class-based views so that we can have all four CRUD methods inside of each class.
Yeah, this is one of the reasons. This is one of the nice things you get with class-based views. There's others as well, but this is a big one. Yeah, and Jason, like you were saying, the method name has to be exactly the same as the HTTP verb. So eventually we'll have, in fact, I can go ahead and let's do just for fun. Let's add a post. And let's do maybe like request.data and let's look at request.data and let's just return a response. And let's also add delete. And actually, I made a mistake here. Post doesn't belong on a Pokemon. Post actually belongs on all Pokemon. Because if I go back here, when I'm creating a Pokemon, it doesn't have an ID yet. So we hit this endpoint that we're using the all Pokemon class-based view for. So let me move this over here. And I'll just rename this a bit. And we can finish up our delete endpoint here. And
So post is the only exception, then the rest belong under the single Pokemon, the other methods.
yeah, Yeah, basically. Because if you think about it, if you go back to sort of these REST API design principles where the URL uniquely identifies a resource, when we're creating a new Pokemon, there's no resource, there's no Pokemon resource with an ID that exists, right? And so we kind of default back to, well, we're creating a new individual Pokemon, but the resource is really like Pokemon in general. We're making a new one. I don't know if that made sense. Did that sort of make sense? Perfect. Yeah.
Yeah,
And
yeah.
every now and then, like login, right? Logging in can kind of mess around with REST API conventions. You usually use a post request, I think, to log in. If you're creating a user account, you would see a post request here as that would be a post request, like post API v1 user to create a new user account for sign up. Um, so Post, I think, is really the only one where you see that. Most of the others, you can kind of uniquely identify something, though it depends, right? Here we have Pokemon and moves. Um, but like as you have more stuff, you might end up with more nesting, like I don't know, we might have like API v1 uh trainer, and then we might have a trainer ID, and then a trainer might have Pokemon. Um, it's so I don't want to say it's the only exception to the rule, but it's by far the most common one. So let's test this out real quick now that I've written a bit more code here. Let me just fix my return statement to make sure that it works. And this is going to be delete. And it's not the worst idea to set up a skeleton like this early on. And now I can go in here, and if instead of put, I do delete, we get something back, right? And I see that I'm grabbing the URL parameter, the Pokemon ID. I see my message over here. Um, if we do post, this is going to fail because there's no post on that route. But if I do that, I think I need the trailing slash. We see that we hit that endpoint that we added here on the all Pokemon route, API slash v1 slash Pokemon. So this is one of the nice things about Django REST framework is it does a lot of the routing for us. I don't need to have like a separate path for get, post, put, and delete. Um, like I don't have to, I, we wouldn't do it this way. It would probably be in here or something. But I can just have one route or path, and then the class-based view handles dealing with the HTTP verb. So I just want to check in and see if folks have any questions before we keep building out our put endpoint. Okay, awesome. Let's keep rolling. So let's build out this put and make it real. I think the console logging is really useful. So I still want to be able to deal with a Pokemon by ID or by name. And let me go ahead and actually let's just do it this way for now. So we're gonna get the Pokemon by ID or name. And I think I'm going to modify my request here, and let's send back the Pokemon just so I can test this as I go. And let's change this back to put. Let's change it back to an ID of 1. And as always, I keep forgetting that slash. And I see that I've implemented that correctly, so I'm good to go. So now that I've got the Pokemon, I do need to actually now modify the Pokemon. So we have to check request body to see what fields we will update. And this is where it just really depends on your models and the logic of your code. And what we're looking at here at the request body is this JSON. So we can have captured, we might want to say level up is also true. We might want to add a move to our Pokemon. Let's just add a move maybe of ID 3 if Pikachu doesn't have it. And let's say we want to change our Pokemon's description. And I'm going to send this request, make sure I don't have any errors in my JSON. And then, in fact, I'm going to go ahead and I'm going to just print out request.data. And data should be everything here in the body of the HTTP request, all this JSON turned into a dictionary. And if I look here in the Django server logs, if you all look down here in my terminal, we see this print statement captured true, level up true, moves 3 description, the classic Pokemon. And that's coming here from request.data. So now I know I've got the data and I can keep on working. So this is where it really starts to depend on the model and the logic of our application. Because if we want to level up, well, we have a method for that. Right? And we can go ahead and leverage it. Same with captured. We have a method for that, change quat status. And I am going to very briefly open up my Pokemon model to make sure I'm using the change quat status method correctly. And yeah, because I remember when we originally wrote this, I didn't take in an argument. So let's just write a new method here. We'll call it set quat status. And what we'll do is we'll do self.captured equals new status, self.fullClean, self.save. And this way, I don't have to worry about breaking code that depends on the behavior of this method right now. I can just write a new one that is very explicit about what it does. And then over here, we can go ahead and we can use it. And let's go ahead and test this now that I've written out this much code. This is a pretty good start, right? We've got level up, we've got quat status. Let's get this working. So what I can actually do now is I can use the Pokemon serializer for other fields and also to sort of trigger the validity check. Like, because for things like description and some other things, like we'll come back to type and move, but description is a good example of where like if it's changed, it's changed. We don't have a helper method or anything like that. So what I should be able to do is we use the Pokemon serializer and we give it our Pokemon, but we're going to pass it this data, request.data. We might have to do a little fiddling with level and quat, but we also say partial equals true. And this is the key step here that tells the serializer that this doesn't have to have all of the data for our Pokemon. And we're going to do some validation. And if that succeeds, we'll just return a response, the status of HTTP. And I do need to go ahead and import that. And let's see here. From Django.http import excuse me, it's not from Django.http. We're going to grab this from Django REST framework, which is even better. From REST framework dot status import HTTP 204. And because we're probably going to need it in a little bit for an error message, we'll import HTTP 400 bad request. So there's a bunch of different ways to get HTTP response codes, but with Django REST framework, we do want to just import it here from REST framework.status. And now that should work fine without a squiggly. I'm going to go ahead and just add a helpful print statement here for myself. And let's go ahead and let's print serialized Pokemon. I think it's validated data. Because I want a bit of a sanity check to make sure that everything is working. And now we do want to write our error handling logic if something goes wrong or the validation fails. Let's print out the errors to help us in debugging, and let's return that 400 response. And now I can get rid of this here because we either have success or we have our error, but we return an HTTP response in both cases. So now let's see how we do. I've got captured, true, level up, moves, I'm adding a move ID. I might need to fiddle with this to get this format right. Description should be pretty straightforward. So this seemed to work. Pikachu is set to true. Level up. So I definitely have to work on my code here, but moves, something changed. Description was updated. So there's some things that are good here, some things that are not, right? Because what's happening is this using the serializer to update this way is getting a little too clever. As you can see, it did a great job of taking what we put in here and adding it to our Pokemon, and updating it. But some of this wasn't good data. Like, I'm honestly a little surprised I didn't get a validation error thrown with level up true. I would have expected that to happen because level up should be a number. So I'm not sure how either in our code or the serializer it let us get away with that. Um, but there's some other issues as well, right? If we look at this with the moves, this kind of overwrites whatever existing moves our Pokemon already had. Pikachu might have had no moves. They might have had one move. They might have had two moves. But the way we've written this code, it's not adding that to the existing moves. It's kind of overwriting them, which sometimes can be good, or if we're okay with it, but sometimes is bad. So this method here with this partial update is really powerful, but we have to be careful, right? Because as we've seen, sometimes we actually want a bit more manual control over the update process. So let's comment this out. In fact, let's comment all this code out and we can come back to it later. But let's build this out a bit more manually just so we can see how that looks, and then we'll take a break. So, and again, this is going to be a bit more of a design choice, but right now, let's just manually go through each of these fields. And let's do if moves in request.data. And this is where I do want to remind myself of how I've designed my Pokemon. If I go back and I look to moves, I see here that it's a many-to-many field. It's probably indeed stored as some sort of array. If I go back to my fixtures, I see here it is indeed stored like that as an array. And I also have to make a design choice here in this put request. When we're doing this, is this a new move that we're adding to existing moves, or are we overwriting? And I think the right answer, it should be we're adding this to existing moves. So what I'm actually going to do is I'm actually going to write a method, and we're going to name it add moves. And what it's going to do is add a list of new moves in addition to the existing moves. And can anyone remind me, how do I like concatenate or combine lists in Python?
Isn't it like
Join.
that?
I
It
actually,
might be job.
yeah, I actually don't remember. What were you gonna say, Chase?
I was thinking .zip, but I don't think that's the answer.
Yeah, let's open up a Python REPL real quick and figure this out. It might be, is it
Is it
append?
append? Yeah, that's what I was thinking too. It might be append.
Yeah, we're
Append
gonna
is to add to a list. I really don't know about joining two lists.
Yeah, if you add a list to a list.
maybe how about concat?
Concat. Yeah.
Nope. So let's actually ask the internet real quick. Um,
I think it's just a plus sign.
oh, it would be that simple, wouldn't it? That is the beauty of Python.
Wow. Nice.
Yeah. So, um, and actually, as I'm writing this add moves, I'm realizing I'm not 100% sure with a many to many field how to sort of add multiple things. So let's maybe quickly Google Django REST framework, many to many add relationship, because I don't think I can just grab it by IDs. Um, I think the moves will actually take a bit more work. Um, by the way, I think there is a way to simplify some of this with Django REST framework and serializers, but certain things like the level up behavior, for example, like if we make the decision that we want like to control leveling up, which makes sense because we also have a validator on level up. If we go way back to this of a max value of 100, and some other things, maybe we don't want the front end to say the new level. We just want to say, hey, like level this Pokemon up. And so that's where like a bit more complexity gets introduced. Um,
Also another thing for moves, like if I remember, wasn't there only like specific moves you could add? So in other words, if you tried to just make something up, it wouldn't be accepted.
well, the moves have to exist in the database, if that's what you
Yeah. Yeah, essentially what I'm saying is it's a move that's already been that's already preset to like, fire lightning or whatever. But if you try to make something up out of the blue, I thought there was a
yeah.
valid that wouldn't accept it.
Yeah, that's true. And that one is less about the serializer and more about the rest of our code. The way you solve that one, by the way, we haven't seen this, but in your front end, that's the nice thing of having a drop down, right? You can get the list of current moves in the database, but our backend would still throw an error. We could change this if we wanted to like look like this. In some ways, this would be the simpler road, right? I think it'll be interesting to see this, and we can kind of implement this manually. And I'll double check during the break to sort of the right way to, if there's a nice way to use the serializer with this. But let's get this one working, and then we can break. Um, so yeah, with moves, as I'm looking at this, um, I think moves is actually a little trickier than I thought. I do apologize because I want to check. I'm not so sure we should just be doing self dot moves plus moves, right? Though this would be, if we just had to think about Pythons and lists, this would join our moves together. But like you were saying, like we need to check that the moves like are already like exist in the database. Otherwise, we'll get things that are messy. Um, so let me come back to this one, and
Yeah.
get a cleaner implementation with the serializer.
Yeah. Also, I guess if they already had the move, you wouldn't want to like duplicate it too. Like if they already had fire, you wouldn't want to be able to add like another fire, for instance.
That is an excellent point too. This is
Yeah.
also, by the way, like update is the trickiest one to get the logic for. Um, and to kind of go back to here, like let's in fact, let's we're going to simplify this dramatically right now, I think, just to get this working. And then we'll break and I think I'll put together a cleaner implementation for us to look at after the break. But the simple version of update is where the body just has values. So instead of level up true, let's do level up, 54. And we're not going to worry about moves for the moment because that one is a bit more complex. And rather than doing this manually, we will lean it into the serializer. And then with the serializer approach, what we have is, in fact, is this. So if we lean heavy on our serializer, the way we would go about it is we do first have to get the Pokemon, the thing from the database we want to update, and we use it to build a serializer, but we pass in the data from the request and we set partial to true. Otherwise, we'll get an error saying that fields are missing. And then we can leverage the serializer the way that we've learned to check for validity, to save it, to send back a response, or throw an error. So let's just watch this one just to see this flow, and then we can take a break. So here we see, like, now that I've kind of modified how this works, this put works just fine. We set captured to true. We set level up to 54. We change the description. If I want to set captured to false and level to 99, we're good to go. If I set level to something invalid, it's something invalid like 101, that's too high, we should get an error thrown. And I'm actually a little surprised we did not get an error thrown here using the serialized Pokemon and saving our Pokemon, because I feel like is valid should have triggered.
Isn't your method for level up just if it exists, then you level up increment by one?
That is the method. We're not using the method right now. I'm just modifying it directly. And we do have on level these validators, this min value and max value validator. And the max value for level should be 100.
Is it because you're not using the full clean method?
Oh, you know what? It's because I'm calling this level up instead of level. So that this was me getting confused with two different versions of the code. Because level up is not the name of a field. We were using this as like a flag, essentially, whether to call the level up method. I think if we change it like this, we should now see the error I was expecting. And now we get a 400 error. Where it says level, ensure this value is less than or equal to 100. And we see over here, printed out the error message.
Yeah, but because you called it level up, is that just adding like another field that doesn't exist and shouldn't not be allowed to do that?
Well, that's a good question. It's done something. I seriously doubt it's gotten added to the database because that column just doesn't exist. If we do select star from Pokemon app Pokemon, and this is why getting comfortable with Postgres and SQL is good, even with Django fields. If we look here, in fact, let me simplify this. Let's do that where ID equals 1, because that's our Pikachu. It looks like none of this has actually gotten saved, which I'm a bit surprised by because they're still level 13. Their description is still unknown Pokemon.
The only valid level you passed, or they only tried time you tried to pass a level was 101, which caught an error, so it shouldn't update, right? You didn't actually update them legitimately prior.
That is a good point. I would have thought maybe like the description, if it didn't throw an error, that it would have been updated. Let's try level 99 and let's see what happens here. So that one succeeds with the 204 no content. If we run the query again, we still see unknown Pokemon. Let me make sure I'm connected to the right database real quick. Should be, but
Well, your level
we'll give
increased, so you should be connected to the database.
oh, you're right. The level did bump up to 99. Interestingly, the description,
Is it because you have a comma after somewhere? I don't know. Just
yeah, that looks fine. I wonder if description is violating some other rule, some other constraint that we have that I would have expected an error there. Yeah, why don't we take a break and I'll fiddle around with this offline because I realize we've been going for a bit over an hour here. So and I'm not sure if I want to give people a chance to take a break, and also that way I can get this working and have like a good, clear answer. The good news here is, as you can see, like updating is by far the trickiest of the bunch. The other fields end up being a lot simpler, like create and update and delete. Why don't we, do you all want to take, should we take like 10 and then we can come back and finish this off and look at some of the other methods?
yeah,
Sounds
that
good.
works.
All right, let's do that. And I think what we'll do is we'll make sure we get through all the methods, and I'll aim to wrap up by 11 Central to give people like an hour of work time before lunch. Sound good?
Yep. That sounds
Awesome.
good. I do have a quick question too, though, Adam.
Yeah.
Can you scroll up back into that put function or method? So is line 38 the actual line that's like actually updating the like instance?
Right. Good question. I want to double check this because I would have expected the Pokemon description to be updated, but it is, so line 38, as you're saying, updates more or less updates the instance, right? Because we now have a serializer. But then on line 42, when we do dot save, is when those changes get saved or persisted to the database.
Okay. And then what was the point of the partial equals true again?
Yeah, without, let me show you all real quick what happens without partial equals true. So if we go back to a put request that we had that we knew was working, like this one here, and let's just make the level 40 so we can see a change. If I hit send, and let me go ahead and let's open up our Django server. We get this 400 bad request method, and it says name, this field is required. Without partial equals true, we will get errors until all the Pokemon fields are in this JSON in our request body. Does that make sense?
It does. Does that still affect it even if it has default values?
I'm pretty darn sure, yes. I'm not certain if like default field names are required or not, to be honest. I would have to check. So I'm not sure there. But for put specifically for updating, there's just so many different fields and like things like name that we would never want to do. You pretty much always want partial equals true for put.
Okay, sounds good. Thank you.
Yeah, great question.
Yeah, I got a quick question, sorry. So this has nothing to do with what's in the Pokemon serializers method in terms of what you're calling.
What,
So yes, so if you go to the Pokemon serializer method, for instance, if you only have like a couple fields in there, that has nothing to do with this.
oh, well, actually, you do raise a good point. I've totally forgot about this, and this definitely does matter. And I think this may have been one of my errors. If we add description now, and let's try this. Again, because we do have description in the classic Pokemon, and let me add a little bit more so we don't throw an error. The classic Pokemon is this one, Pikachu. We'll put a period at the end. I can't remember our regex, but just in case. So if we hit send, we get success. If we go to pSQL, in fact,
That was it.
yeah, the description was updated. Good call. I
Okay,
totally
so
forgot about
okay, so it has to be in a serializer method then. That was the reason it wasn't working.
Correct. Correct. And in fact, the answer to that is using the special serializer method name. Have we seen this? Have we discussed this yet? All?
Yeah, I think the reason we were specifying fields is because that's what the prior assignment had us do, when it came to, the specific JSON objects I was asking for. But in this case, if we're going to get used to using CRUD, then we probably just want to go fields all just to be
Yeah.
safe.
Yeah, exactly. Um, this is, I think, a good starting point for most stuff. You can make multiple serializers for the same model if you want some for specific things. But yeah, that's a really good call, Jason. I totally forgot about that, and that was definitely part of what was going on there with the description. All right, why don't we actually just do 15, and then when we come back, we'll finish off our put endpoint, and we will also look at create and delete, and we'll look a little bit at testing, and then you all should have about an hour to start getting your hands on this stuff before lunch. Sound good?
Mhm.
Yeah, great questions, folks. Thank you. All right, have a good break. I'll see everyone in 15. All right, so we are deep into building our put request, and we got a good amount of it working. Like over here, if I have Pikachu and we're making a put request and we want to change them from false to true and from, I don't know, level 40 to level 55, and we want to change Pokemon description and we want to change their moves. Most of this is working. If I go ahead and I hit send, we get a 204 no content response, which is good. It means this succeeded. If I look here in my print statement, I see everything that I want to see. I see the levels changed. I see the new description. But as we saw before, some of the times this wasn't getting saved to the database. So it's helpful to query the database. And now looking for Pikachu, we see their level 55. We see captured is set to true. And we see the description. If we look at the Pokemon moves, though, it tells a slightly different story. And this is the table, remember the join table that links a Pokemon with a move. And if I look here, I see Pokemon ID 1, which is Pikachu, has moves 1 and 2, which is not what we were saying over here, that we wanted to change it to move 4. So what this tells us is that like our current setup with the serializer isn't doing this. And even worse, it's not throwing an error. And even worse, the print statements I'm getting back are a little confusing because I see moves 4 printed out here. So we're going to do a couple things to make this a little easier and to also then make our debugging a little easier and maybe add some moves manually. So first off, if I look over here, this validated data that we're printing out, that we're getting printed out here, isn't that helpful because the serializer doesn't know what it doesn't know and the moves don't get updated. What I really want to do is I really want to get my Pokemon from the database. Now, because we can pass both ID and name in this endpoint, it can make the pattern to look up the Pokemon a little trickier. And in fact, because this is going to be really useful for all our other code, I'm going to make myself a little helper function. And so I'm going to go ahead and just copy this code. And up here at the top of this class, I'm going to make a method named get a Pokemon. And this is going to be our helper method to get Pokemon from the database by name or ID. And so now I have a method where I can pass in the Pokemon name or ID or whatever it is, and we'll get back our Pokemon. And I should be able to use it now over here. And note too how this makes this code like way cleaner to read. And let's just print out the Pokemon. But this is also going to be useful because now down here, when I'm printing stuff out to help me make sure I'm using my serializers and stuff correctly, let's go ahead and grab that Pokemon from the database again and print it out. And that way I don't have to get, I like if the serializer isn't doing something right, we should be getting the Pokemon from the database. And let's see if this works and make sure I don't have any typos, and also see if it helps us debug our problems a bit more. So this seems to work fine. It looks like right here is where we get our final print statement. But in fact, I'm not totally sure. So let's.
Before, when you ran
Yeah.
that and it said Pokemon updated, it was just an empty object. It wasn't actually, there was no data there.
Yeah, I had I had something wrong in that line of code as well. So let's in fact modify this a bit. Let's do updated Pokemon. Let's give this a variable so I can do something with it. And let's print the updated Pokemon, and let's print the updated Pokemon moves, right? Because that's what we're interested in. And then, by the way, if we wanted to, what we could also do now is in our response, we could return the updated Pokemon as JSON data, which I'm going to scroll up a bit to remind myself of the pattern. And I think I can just do updated. Well, really, we should just be able to do serialized Pokemon.data. And if that works, we get back the updated Pokemon, we get back their data. We see that all these other things are changing. Like, let's go ahead and change type from ghost to electric. But we see that the moves aren't really working. So there's some missing steps here. We can also see that the serializer or the move app doesn't even know how to get the different moves. Where I'm printing out, this should probably be dot move. Because I think that is the name of our model. Oh no, it is moves plural. So we have some work to do here to see the moves. And I think I'll come back to that later because that is important, but I also want to make sure I cover the other things that we have to here. Um, so if it's good with folks, I think what I want to do is I want to implement create and I want to implement delete. And if we have to deal with moves, we might do that along the way and do a little bit of testing, and then we'll circle back to moves. Does that sound good? Awesome. Chase, yes, sir.
Yeah, I think I might have missed it at the beginning, but you created a helper function to check if it's an ID or a name. How did you specify in the URL that it could be either a integer or string?
Right. Totally. So if we go back to your URLs PY for getting an individual Pokemon, this was a couple days ago, but we actually wrote a custom, it's called a converter in Django named interstring. So instead of here, this being str or int, we're using our custom one into a string. Um, and I won't go through this in full, but we wrote this a couple days ago, and if you want to write a custom converter for a URL path in Django, this is how you do it.
Okay, thank you.
Yeah, totally. And as you can see, it's a bit of a double-edged sword, right? It's convenient, but it now means like all of our logic, we have to keep that in mind. But the good news is this is actually a really nice pattern, this helper function to get a Pokemon by ID or name. And we can use this everywhere now. So this will in fact make our life a lot easier. In fact, we can use it over here and get Pokemon, though I won't modify it right now. And we can use it wherever we need to. I am going to make a note for us to come back to here. And the note is going to say like handle updates to moves many to many. You know, part of what is also going on with moves that we haven't implemented is if I make this update and I look at our print statements, I see here like move app.move none when I try to print updated Pokemon.moves. And so that tells me that I think even just for printing out multiple moves, there's something that we need to add to the serializer. So there's probably a couple steps here. But let's go ahead and let's handle creation for creating new Pokemon and deleting. And just to recap, to look at those endpoints, create is going to be a post, but it's not going to be on this same route that has a Pokemon ID or name, because when we're creating a new Pokemon resource, there is no ID or name. And then when we get to delete, delete will be for a specific Pokemon ID and name. So let's go ahead and let's go to our, in fact, we have skeleton code for this. We have post over here. Let's start building out our create a Pokemon. Endpoint. And the good news here again is modifying data is by far the trickiest. Creating data and deleting data, the logic ends up being a lot simpler, and we can leverage serializers for this. Though we may find we need to tackle the moves issue as well. So we can use our Pokemon serializer, not surprisingly, to create a new Pokemon. And to help kind of make clear what this would look like, let's make this a post request and we'll send it here. And what we'll do is we'll use, excuse me. We have a lot of Pokemon in there. Is there a Pokemon name? We have what? Charmander, Blastoise, Eevee, Pikachu. So
You do Ivysaur.
how do I spell that?
Ivysaur.
Oh, like an Ivysaur. Got it. Okay, so I just want an interesting description in there. Um, and as a friendly reminder, as to your point, Jason, I was looking through the valid moves, and we have 4 of them, right? So a move ID, 1, 2, 3, 4, all should be good. So let's just do 2 and 3 for Ivysaur. And just for fun, we'll have Ivysaur not be captured. And so right now, this post request doesn't do anything, but it does tell me I have an error in my JSON. It looks like it's line 3, column 3. I forgot a comma. So this is why it's great to always run your code. So we haven't created a Pokemon yet because I haven't implemented that code, but we can see that we hit the endpoint and we get data printed back, right? And that's all that our post endpoint does. So now let's actually create a new Pokemon. And the serializer does make this very easy, though as we saw, we'll have to kind of circle back to dealing with moves correctly. And we're going to send back an HTTP 201 created status code. I do need to import that from up here. And again, we're importing these from REST framework statuses. I'm just going to kind of scroll back down to where I want to be. So now our Pokemon should be created. And if not, let's return an error. And we'll print out the errors. And we'll also send back a status code of HTTP 400 bad request. Which, to be honest, is this a 400? Is it the client's fault? Is it the server's fault? We don't actually know. That's okay. That's okay for now. And to help us debug, well, I think the easiest way is we can just look in the database. We can also see real quick if this save method returns anything. Because I think it might, if it returns an ID, that would be really nice. So let's check out their docs real quick. Let's see if it tells us. So save, it does tell us it returns an object instance based on the validated data. Calling save will create a new instance or update an existing instance. So this should actually give us what's from the database, right? So let's in fact let's call this saved Pokemon, and let's return that just as a sort of like double check. And then we can also print out saved Pokemon, and we can print out saved Pokemon.moves because that's where we know we're having issues. But this way, like this should give me more information about this Pokemon. And in fact, let's print out saved Pokemon.id because that's the one thing that saved Pokemon will have that new Pokemon probably does not. So now I've got some good print statements to help me debug and see what's going on. Let's go ahead and run this creation request again for Ivysaur. And it looks like we have some sort of error. Pokemon object has no attribute data. So this is probably because save isn't returning a serializer, it's returning a Pokemon object instance, if I had to guess. But if we scroll up a bit past these error messages, we see here that in fact these other print statements on lines 106, 107, 108 work just fine. Ivysaur is yet to be caught. That's our Dunder string or Dunder repper print for Ivysaur, Dunder string, I think. 7 is Ivysaur's ID. And again, there's no moves. And now if I also just to double check, go to the database and we search for all of our Pokemon and we do a query, we see all the way down here at the bottom, we got Ivysaur, right? And this actually touches on a really good point that just because there was an error here, all this other stuff succeeded and Ivysaur was saved to the database. And so if I try to save Ivysaur to the database again, I actually get a different kind of internal server error. And if we go over here to our Django code, this error, let's see, object of type Pokemon is not JSON serializable. Interesting, it's a different error. I honestly would have expected another error that like we can't have two Pokemon with the same name. So I think we need, let's see. I'm trying to remember. Import JSON, and we probably want is it JSON dumps? We might have to play around a bit to get the data coming back in our creation request, right? Sorry that I'm jumping around a lot here. Because I'm a bit surprised object of type Pokemon is not serializable. I suppose we can do Pokemon serializer saved Pokemon, not data. And that this might be overkill. In fact, this might not really have been worth the effort now that I'm kind of writing all this out. But I think that will do it for us. Yeah. And so now, indeed, we've got Ivysaur. Um, what this tells me is we may have forgotten something in our data model for Pokemon names because we sure seem to be able to make a whole bunch of Pokemon with non-unique names because we have 3 or 4 different Ivysaurs in here. And if I hop over to our models, we see indeed that we never made the name unique, right? So that could be something that we add later. And it probably makes sense, but I'm not going to worry about it right now. But it does point out, like, if this was unique, I was expecting this to fail because Ivysaur would have already been in the database. So as you're working on this stuff, you do have to think more about what data do you have, right? Because sometimes like doing the same thing multiple times will produce errors for different reasons now, if that makes sense. So I just want to check in and see what questions folks have around creating and adding to the database, or kind of like any of the code that we were going over and discussing there.
We're still not getting any moves when you create new Pokemon.
Yeah, that's correct. We're not getting any moves right now. And that's because the serializers need to be modified to handle moves. I think I want to show that last, frankly, because I'm worried I'll make a mistake and it might suck up a bit of time. If we wanted to do it manually, like one way to do it is, we could just, it would be a bit of a pain, but the manual way to do it would be, so first we have to have created the Pokemon. And then we would probably want to do something like new moves equals requests dot data dot get moves. And then we want to do like if length of new moves is greater than 0, right? I want to make sure that there's something in there. And then let's do for M in new moves. And let's just print out M right now. Let's just make sure that this code I wrote works. But where we're going to go with this is we're going to manually add each individual move to our Pokemon. So if I run this, and indeed, let's see, greater than not supported between a type of length list and int. And that's a typo on my part in the code where length is right there. I think I was thinking of JavaScript where the if statement needs to be in parentheses. But this is why like running your code all the time is good. So this is good. We're printing out moves 2 and 3. So what we need to do now is we need to, like you were saying before, get the move from the DB to make sure it exists, and then add the move to the Pokemon, and then save. So let's just call it let's call this move ID so I don't lose my mind. And then we'll say move equals move dot objects dot get where ID equals move ID. And now I do need to all the way up here from move app dot models import move. And now if I hop all the way back down here to my code, where we're doing this move.objects get, that should give me the move. Let's print this out just for sanity. Now I should be able to do Pokemon dot, in fact, it's got to be saved Pokemon dot moves. And now here's the question where I'm, to be honest, I'm actually not totally sure what the right like method call is to add something to a many-to-many relationship. Maybe it's going to be plus equals. I honestly don't know.
Could you not just do like the dictionary notation with the brackets and then setting it equal to moves?
Um, do not the dictionary on which line?
Like instead of the dot moves, could you do like say Pokemon bracket notation moves equals move?
Oh, like what you mean like this? Might be
Uh,
misunderstanding.
yeah.
Maybe the short answer is I'm honestly not sure. Um, let me run this and see how it goes and see what error messages we get because I think that will help. Let's make sure we get the move. I'm, as I said, I'm a little rusty on many to many. I also think we may have to do some like modifications to one of the serializers, but let's see how far we get with this. And then Chase, you may be right. So if we run this, not surprisingly, we see a couple errors. Unsupported operand type plus equals, which was kind of what I expected. but move is none. We do get the water punch move, which is good. So now I think just Django models. I'm kind of searching how do I add like a many to many in Django. And I think I overcomplicated this. Um, the good news here is actually I did a quick Google search like Django add many to many. And I think we may actually, Django may just have given us an add method. So let's see if that does it. And this is Django models, right? We're not using the serializer right now. So it seems like the add worked. It didn't break anything. We're not really seeing anything printed, but let's try full clean and save Pokemon. Save. Um, and then let's try print. Saved Pokemon moves. Let's try printing out like the very first of the saved Pokemon moves and see if that does anything. Um, so let's go ahead and clear this. We have an awful lot of Ivysaurs, but that's okay. So that mostly seemed to work. That print statement, it did not like that. So I'm just going to get rid of that because everything else seemed to do okay. Um, and in fact, if we look over here at the 201 created, now we've got a water punch move with ID of 2, and then the tackle move with ID of 3. And if I really want to double check, I can go here to select star from Pokemon app, Pokemon moves, and our most recent Pokemon with ID of 17 has moves 2 and 3 created. So this was what I was spacing on for the models. We can just do dot add. As you can see with moves, with the many to many relationship, it does get a little trickier in how to like print and manipulate them because it's not actually like a list, a straight up and down list of objects. Um, but like this is, we could use this same pattern in update if we wanted to, right? And this would be the easy way to do it without having to worry about serializers. I will follow up probably during lunch with how to do this with serializers as well. But this is good to see because sometimes we do need to do stuff manually.
What would be the benefit of doing it with serializers?
Really just once you get it working and like adding whatever is missing, then I don't need to write this code. And the same way that with serializers, we kind of get more reusability, we would probably get more reusability with this as well. Like
But
how
when
do I,
if you're going to write this into the code, then it's going to be reused just by the nature of it being a method. And then your serializer is still going to work when you go to your endpoint, right? If you're trying to request.
I think it depends where we put it. Right now, this is only for like the post request. My guess is we're going to end up writing something like this that's actually going to live in the serializer.
Okay.
Yeah. So that's sort of the difference. And then that way, like if there's like multiple points where we need to add moves to a Pokemon by putting it on the serializer code, we have it in one spot. I think one thing, as long as I'm showing this pattern, the one thing I do want to show is like something that's a good habit is let's put let's grab our Pokemon moves here and then let's actually remove moves from the data. So we're going to now do um delete request dot data moves. And the reason is we're handling moves outside the serializer. So I wanted to show this because sometimes we might have stuff that we don't want the serializer to use. For example, in a put request, maybe we have level up, not level, right? And this is not actually a field, right? We're kind of sending a command to Django if we want to change a Pokemon. So what I might want to do is all the way up here in my put request is before I do the serializing, I might want to do level up equals request.data.get level up, delete request data get level up. And then maybe it's a little bit tricky to figure out exactly where. I think we'd probably want to do it here is after we get the Pokemon, we would want to do like saved if level up equals true, save Pokemon level up. So this is just to sort of show this as an example where sometimes we might have something in the body of an HTTP request that doesn't directly map to a field, right? And the nice way to handle that is grab it, but then delete it, because this way I can just pass this request.data into the serializer and it doesn't have stuff that doesn't exist as a model field for the Pokemon serializer. So I just wanted to check in if folks have questions around that, because that's a good technique to see and that we might use once or twice. Cool. All right, let's go ahead and let's add deleting. And deleting is by far the simplest. We've kind of saved the easiest for last. When we delete, we indeed delete an individual Pokemon, right? The ID will be passed here. So this is going to be on our A Pokemon view. And just down here, we have this sort of skeleton delete. And let me just go ahead and delete this commented out stuff, in fact, that we don't need or want. And we're going to use the get a Pokemon method that we wrote before as our helper, which will make life a lot easier. And all I have to do now is call Pokemon.delete. And I'm pretty sure this returns, yeah, let's see, it returns a tuple. I'm pretty sure the int is maybe the ID of the Pokemon. I'm not sure what the other part is, but let's find out. Let's just do A, B. And for our delete, we're just going to return a status code of HTTP 204. We might return some extra data. It's not the worst idea to return the ID of the thing that you deleted or some information about it. But let's just get this working, see what this delete method returns, and then we can modify anything else that we need. So I've created all these Pokemon with all these different IDs. If I go to select star from Pokemon at Pokemon, there's so many Ivysaurs. Let's delete Ivysaur with ID 16, right? That's not the one with the moves, but it's the second to last one. This does raise a good point, which is that we really should make the names unique especially if we look that we've designed our REST API where it can accept a Pokemon name here. Because right now, without unique names, which Ivysaur are we looking at? We don't know, right? And stuff like that pops up as you design stuff, and it's pretty normal to have to refactor as you go. And the beauty of Django models is it makes it pretty easy to add that. Now, if we add that, it will complain about there being like duplicate names in the database. And I don't want to deal with that now. But that's also why it is really, 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 really nice to have moves and Pokemon in your fixtures. Because our flow, if we did decide to make a name unique now, like this, if I just did, unique equals true, I would have to run manage py migrate to create a model, then make migrations. Then I would get an error saying there's duplicates in the database. So the easiest thing to do at that point is to just drop the database completely to delete it and then rebuild it. Right? Since we have fixtures, we drop the database, we apply the migrations, and then we load our fixtures in again, and we're good to go without missing a beat. And that's a good real world example of why it's not uncommon to have to drop your database sometimes during development. But so for us right now, testing this delete method we wrote, we just need to remember to deal with IDs and not names. And let's go ahead and run this. And let's see, interesting. Connection refused by server. I wonder if it's because I have stuff in the body of the HTTP request. Oh, it looks like I have a typo. Cannot delete function call. I see. So sorry about that. The issue here was I got a little too excited with this. We can't use .get to like access a dictionary when we're deleting a key. I think we need to do it like that. And then I do it. I delete it the right way there. So let's see if our server runs now. Looking good. And now let's try to delete. And I need to end it in a slash. And now it does appear that we successfully deleted our Pokemon. If I go to pSQL and run the query again, indeed, I've got ID 15, but no ID 16 and then ID 17. And if we look at our print statements for what that delete method returns, let's see, where did I put delete? There we go. We see that the first thing it returns is the ID that's been deleted. And I'm not quite sure what this is. I would have to look it up. I wonder if it's like the number of things from each of these like tables that have been deleted. I would have to check. But so let's just call this like ID and metadata. So if we want to, we could return the ID of the thing that's been deleted. It's not the worst idea. Sometimes that's useful to have on the client. So you can do something with it, but it's not strictly necessary. So it's really dealer's choice. And that is deletion. So deletion is again by far the most straightforward. I am curious. Yeah, I think what it probably deleted, what it was telling us was that it deleted something from the Pokemon app, Pokemon Moves table. Because if we look here, oh, 16 didn't have anything, but 17 did. Well, let's go ahead and delete Pokemon 17 and see if these go away as well. And then I think it'll be a good time to move on from delete. So that one succeeds. If we go here and we see what's printed, this dictionary that it returns, this is indeed telling us like the number of rows deleted from each table. It's telling us it's deleted 2 rows from the Pokemon moves table and 1 row from the Pokemon table. Or if you prefer like 2 models or model instances from one and one from here. And that's just useful metadata that sometimes we might need, but we don't really need to worry about. And now we should see these 2 Pokemon move rows being gone because Pokemon 17 no longer exists. So we don't want to keep track of what moves it has. And if we look, indeed, that data is gone from our database. So again, there's a lot of moving parts with Django models and serializers, but when you do hook it all up, it is quite powerful. What questions do folks have around delete? Okay, cool. Let's take a quick look at testing then. I realize I ran a bit long, but I do want to make sure that we get the chance to look at testing. And I was just looking at the models now because I was curious if we had a cascade set on any of these. And if we look at Pokemon moves, we can see that we don't set a cascade, but there's some sort of default value so that when the Pokemon's deleted, the moves themselves aren't gone, but the record of the Pokemon moves are. And just one moment. Okay. Why don't we actually take 5? I actually need to grab a glass of water, but when we come back, then we'll look at tests. Does that sound good? All right. Thank you, everyone. Thanks for your patience. Let's take 5 and then we'll look at tests. So we've covered a lot of ground here. We've talked over REST APIs. There's this term hate OAS, which is this crazy acronym, hypermedia, as in like hypertext and links and HTTP requests as the engine of application state. And I think what we've started to see is how we really can use a REST API to change our application state, right? This is an interface that any client can use, whether it's Thunder Client or a React app, to create Pokemon, to delete Pokemon, to, if we have special logic for things, leveling up Pokemon, right? Where this isn't just about sort of straight up and down CRUD of modifying existing fields. Like we can pass essentially a sort of Boolean flags commands that we want our backend to run. And then in our code, what we can do is we can look for those special flags that we might pass in the body of an HTTP request, like leveling up, and handle them separately, right? First by grabbing them, then by deleting them from request.data. So when I pass request.data into my serializer, it doesn't have things that aren't actual fields. and then by writing custom logic that we can use alongside the serializer. And we saw how in the create a Pokemon method over here, because we haven't hooked up our Pokemon move serializer yet, so that we can really create a bunch of moves for our Pokemon, and we had to write this logic manually, that we in fact can just grab those moves from the body of the request that gets sent, delete it from that so that this still has the rest of the data. And in fact, a nice pattern with this could even be making a copy of request data, which I think I'll try to show later, so we don't modify the original version. But that lets us play with this even more. And then we can manually create Pokemon moves using models and model logic that we learned earlier in the course. And we saw also that deleting a Pokemon is by far sort of the most straightforward of operations, which is usually the case. Delete, probably followed by get, right, to read are the easiest. Update is always the trickiest because changing something once it exists, modifying state is always the trickiest, and create is somewhere in the middle. Let's go ahead and let's write some tests for this. So these tests are going to live in our test views file that's here in this tests directory at the top level inside the project directory. And the same way the other day we wrote a class specifically for the noun project API. Well, actually, we can use this existing one that we have for Pokemon because we have an endpoint here to test getting a Pokemon, getting all Pokemon. Let's add some for creating and deleting Pokemon. And let's start with delete because I think that that is the easiest one and it will get our brains going. So remind me, like, what are the steps that this test has to do to delete a Pokemon without kind of like writing code, but just like pseudo coding this? What do I want this test to do?
It needs to check if the Pokemon exists in the database.
Okay. And then what?
If it does exist, then it needs to delete it or run the command to delete it. And then it needs to check to see if it was deleted.
Am I going to delete it by doing Pokemon dot like
No,
object?
no, you're not going to do it manually. You're going to do it through the delete method that you created.
Right, exactly. Right, it's going to be like delete API v1 Pokemon ID. And in fact, this part we don't even need to do because we can let the code that we wrote do it for us. And let me go ahead and let's move our views over here. And if we look at this delete code, we have self get a Pokemon. Actually, as to your point, there is a modification that we can make here that will make this easier for us.
Shouldn't it return an error if it doesn't exist?
Exactly. And there's actually a really nice Django shortcut that we can use and that we can modify to do this. So from Django shortcuts, we're going to import a method called get object or 404. And as to your point, Tim, this is actually super useful. And it's just useful in general for all of our code. And so what this does, as it kind of implies here, is it's going to try and get an object from like an instance of a model from the database. But if it doesn't find it, it'll automatically return a 404 code, which is basically not found. So over here in this get a Pokemon method, I can go ahead now and I can modify this and I can say return get object or 404. And let me make sure I do this the right way. I think the first argument is the model name. And then the second one is going to be the ID matching. And let me just look in fact at the guide code. And in fact, let's take a quick look at this in the Django docs because this is useful to see. And this is what I'm looking at. So get object or 404, it calls get on a given model manager. But if it doesn't find what it's looking for, it will automatically raise an HTTP 404 error, which also sends back a 404 HTTP response. And there we go. It is indeed like this, where we give it the model name. If we're looking up by primary key, we do PK, but we should also be able to do it by field to do like, I think we should be able to do it by name equals 1. And indeed, we can see here, we can do all the fancy sort of field querying stuff here. So over here, I can do in fact, I think this will just work with ID. And over here, we can do, let's get rid of that old return statement. Get object or 404. But get on the Pokemon model. But name equals ID.title. And in fact, let's test this out real quick. Let's just do Pokemon equals self dot get a Pokemon ID. And let's quickly hit that get endpoint. And this is just my manual test to make sure I haven't done anything silly in this refactoring. And indeed, it gets me back Pikachu. And if I do instead Charmander, it gets me back Charmander. So I can be pretty confident that this refactor worked with get object or 404. And in fact, let's do Charmander and we get a 404 not found. So we've tested our failure case. And now we know our code works when writing our delete test, and we can leverage it when writing the test. Because like you're saying, Tim, we absolutely do need to make sure we're checking that the Pokemon exists. And now this lets us dramatically simplify this process, right? And just as a friendly reminder, Django creates a brand new database when it runs all the tests. And unfortunately, I don't think it creates a brand new database between each test. I think we need to add an additional configuration. So unfortunately, I think after deleting this Pokemon, it may impact future tests, but these fixtures will get loaded in when it runs this whole class. So let's go ahead and we need to create a Pokemon first. Well, we can actually use an existing Pokemon because the fixtures get loaded. So let's just try deleting an existing Pokemon, and we can refactor this more later. So we're going to use self.client that we created in our setup method here. And this is where the HTTP client gets really nice. I can just call delete. As a friendly reminder, client is this API client that we imported. And in tests yesterday, we did self.client.get and so on. So here we can just do delete. We use reverse to give it the name of our path, which is just a Pokemon, instead of having to pass the whole URL. And then for args, let's do Pikachu. And now we just need an assertion. that the response.status code is indeed 204. If we wanted to, we could make this a bit fancier by like checking, like have delete endpoint return an ID and check ID. If we wanted to, we could also query database to make sure only Pikachu was deleted. If we wanted to make this test more robust, but this is a pretty good starting point, right? It tells us that the Pokemon we're asking it to delete was successfully deleted. These were both good to make the test more real. In the interest of time, I'm just going to leave them as to-do notes. But let's go ahead and run these tests just to make sure there's no typos or anything like that. Let's see how we do. So it looks like something actually did go wrong here. Failure. Oh yeah, we're gonna ignore these failures. I should update these, but these are from as we've changed the Pokemon serializer. We did not change the fake data we're using for correct answers. So let's not worry about those. The important thing is the delete test works. I'll double check here. In fact, let's misspell Pikachu, and now this test should fail because we don't get a 204, we get a 404. And indeed, we have a third test failure. And for our most recent test, it sent back a 404 instead of a 204 because I misspelled Pikachu's name. So that's a pretty good sign right there.
What did that reverse do after .delete?
Yeah, absolutely. Let me open up URLs py real quick. So all these names that we've been adding to the URLs in the URLs py files, we can use those in this reverse method. So reverse basically looks up a route, but it does it using the name. So reverse as in if the normal way is the actual URL, where we're using the name to get the URL and go backwards. Does that make sense, Tim?
So it knows to call the a Pokemon instead of all Pokemon because it's a name.
Exactly, because we set name a Pokemon right here.
Okay.
Yeah. So that way, like, I don't have to do, self clients delete. I don't know what it would look like. I'm just making this up, but URL.
Maybe like Pokemon API v1 Pokemon name.
Exactly.
Yeah.
Yeah.
Okay.
Django has like a route object of some sort or a path object. So it also has some sense of these as objects. So this just lets us hook into that.
Okay. Thank you.
Yeah, totally. The name shows up in some other places as well, but this is one of the most useful things for it. And if we scroll up here, we see we import it from Django.urls too, which is just a clue as to what its job is. It's to use the name to give us a URL. Let's go ahead and let's create a Pokemon. And I am going to keep delete last because we are deleting someone from the database. So let's do test 203. Create a Pokemon. And so here, first we're going to create the Pokemon via HTTP request, and then we have to check the Pokemon was created. And we can do a little more checking here, and we'll build that out as we go. But let's go ahead and let's make this Pokemon. So again, we're going to do response equals self.client.post, and we're going to use reverse. And this time the name is all Pokemon, since this is the route that I want to hit, API/v1/Pokemon. But since it's a post request, it's going to get handled by this post method right here. And I am going to make a dictionary here with our new Pokemon information to make this a little easier just to read and work with. I think this gets turned into JSON. I'm just going to put everything in double quotes to keep life simple. And what does Geodude evolve into? Apparently he evolves into a Graveler as I'm looking at our curriculum. And Geodude is going to be captured. And we're not going to give Geodude any moves. Though actually moves would be a good thing to test. Did we add moves to the database with fixtures? We did. So I am going to give Geodude a move, but if we see an error here, I may just delete it because we know that moves can be a little tricky. But we did implement this for creating a Pokemon. So this is our new Pokemon data. I'm going to pass it in here. Like so. But I do also need to set the content type of this HTTP request. The browser does this for us when we send something in the body of a request, or when I'm using Thunder Client. Somewhere in here, it might not be showing us if I hit raw. Somewhere in here, this HTTP content type header is set. But we need to tell the server that we're sending it JSON data. So this is the HTTP request to create Geodude. This is the response that we get back. Let's do a couple tests here. Let's use a subtest so I can have a couple different assertions in here. First, let's make sure that the HTTP response code is what we expect it to be. And we're expecting a 201 created response. And let's go ahead now and let's make sure that Geodude exists. And there's a couple different ways we could do this, but we might as well do it with another HTTP request since that's sort of the level that these tests are at. And I think, in fact, I'll name this response get Pokemon just so I'm not overwriting the old one in case we need it. So we're going to make a GET request to the A Pokemon endpoint. And as you may be guessing, we're going to have it look for Geodude. And then what we can do here is we can do self.assert true.
You capitalized it when you created it.
Oh, capitalize. What did I capitalize?
When you did the new Pokemon dictionary, Geodude is capitalized. Does that matter for your args?
Oh, good question. It doesn't because I've been baking in capitalizing the first letter into our get Pokemon method because we had capitalized stuff right off the bat. We shouldn't right here with the ID title. We really shouldn't have done that, but we did, so I figured I would just run with it.
Okay.
Yeah, that's a good catch though. And you know what, to be honest, well, since everything else is this way, I might as well keep it that way, but you're correct. I think this is actually the better way to do it. And we can assert and we can test here that Geodude's name is what we expect it to be. And my apologies, I didn't mean to jump there in the code. So now we've got a dictionary for our Geodude Pokemon. We do a post request to create it. We do a subtest to confirm that we've got a 201 response code. And we're making this like an extra robust test by actually hitting the get endpoint to test that Geodude exists. So let's go ahead and run this. And I'm going to exit whatever's going on over here. And I'm going to go back to where I ran the tests before because I have my virtual environment activated here. And again, I know there's those two failures that are sort of annoying from the other ones, but these are both working to kind of test my test. Let's change this from a 201 to 200. That should cause an error. Let's change this as well, and we should see failures, but the failures should be what we expect. And indeed, I see here 201 does not equal 200. That's a good sign, right? Because that's not what we want. We're sending back a 201 created when we hit that post endpoint. And I am a little surprised. Something does not seem to be working with this assertion on line 89, unless it's creeping in. Nope, because we have get a Pokemon. So I want to make sure we're getting to lines 89 and 90. So we are indeed getting there, and we indeed get a response. Oh, I kind of outsmarted myself here. So I gave this a different name because I didn't want to just overwrite this, but then I forgot to use it over here. So let's just keep it simple. And now this should work. And let's get rid of that. And now let's see if we have a failure there. Interestingly, no. Let's change this to assert equal. And let's also do something I know will fail. And then if this doesn't work, I may just debug this offline. But I want to make sure this last part of our test is working. So here we go. Reverse for a Pokemon with no arguments not found. Test 3, create a Pokemon. I think I actually have a typo here in how I make the HTTP request, and that's what's been causing us issues. And if I had to guess, I probably forgot to put this in a list because args is indeed a list. Like if we go up here, Pikachu's wrapped in a list. So I think that typo of mine may have been what's causing it. And just to recap, what kind of gave me the clue was really I had to scroll up to the top where test 3 was failing. And then where it said here, no reverse match, reverse for a Pokemon with no arguments not found. And that tells me that somehow this argument wasn't getting passed in. This is also a good reason why you don't want to let kind of failing tests like the ones I had here sit around, because it does clutter stuff up and it made it harder for me to debug. But now that part seems to be working. When I run these again, I think. But yeah, there may be, I may have to come back to this one. I apologize because I know that we're past time. And I think at this point I may just have a typo or something I need to resolve because I was expecting to see like more of an error here. But I wasn't getting it. But we do get a 201 response, which is good. And frankly, the other way to do this is we can do, like Geodude equals Pokemon objects get name equals Geodude. And I think I would have to from Pokemon app models import Pokemon. But now we can grab Geodude, we can self assert equal, just a sort of sanity check, frankly, that Geodude's name is what it is. And I do want to poke around to make sure that this is working, but here's just another pattern that we can see where if we need to check that something exists in a database. Why don't we pause here and we can break for lunch because I realize I ran a bit long. I will make sure to get a good example of code posted up with using serializers for put and a test for put as well, because I realized we didn't get there. But we were able to see most of the patterns that we would use. And for today, your homework is going to be just building on what we've been doing again with the school app. So step 1 here is with the school API to write some CRUD, to create a grade, to update a grade. And this should be more straightforward because we don't have a many-to-many relationship that we have to deal with here. So update should be easier, and deleting a grade for a student and a subject. And so you will need to think about your URL path here. And then for student creation, update, and then for subject, create, update, and so on. And this could be a good part of the day right here, because this is the basic CRUD. So that's okay if that takes a while. And then we have sort of to add stretch onto that, a to-do list where we've given you really endpoints to build your own CRUD, to build the backend for a to-do list. And it looks like this actually might be the same assignment. All right, folks, thank you. Thank you for being patient. I realized there were a couple twists and turns today. I'll have the code pushed up in about an hour. It's an open workday, no pairs. So let me go ahead and stop the recording and open up the breakout rooms. And I'm more than happy to stick around if folks want to go over code for a bit. I just don't want to keep people, as I know we ran a bit long into lunch. All right, let me go ahead and stop our recording.